Hello and welcome to Kashmatics. In this tutorial, I'll be going through some rate of change questions. First of all, I'll explain what rate of change means and then I'll go through some examples of how it's used. So, what are we waiting for? Grab a pen and some paper and let's get started. Before we start the examples, I'm just going to explain what rate of change means. So if a question mentions a rate of change, it means a derivative with respect to time. So let's have a look at these three statements here. The area of a circle is changing at a rate of 10 centimeters squared per second. So that suggests that dA by dt is equal to 10. The next one, the population P is changing at a rate of 200 per year. So dP by dt equals 200. Now with these two here, I'm actually assuming it's increasing. Okay, so the area is increasing and the population is increasing. Otherwise, if it was decreasing, these would be negative. All right. And this last one here, fluid is leaving from a container at a rate of 45 centimeters cubed per minute. So the actual volume inside the container is reducing. So we'd say dV by dt is equal to minus 45. Now the other thing you need to be wary of is the consistency of the units in whatever expression or formula or equation you end up generating. So if one part of it is in centimeters cubed per second and the other one is meters cubed per second, you need to convert one of those units to make sure everything is consistent. So hopefully that's explained what a rate of change actually means. So let's do some examples and see if we can apply it. This first example is probably the easiest type we're going to get. So let's see what we've got. We've got a equals a quarter pi r squared, and then we're told dr by dt is equal to 6, and we need to work out what dA by dt is when r equals 2. So let's just write down what we want to find first. We want to work out what dA by dt is. All right. Now, from this, we can't actually work out dA by dt, but what we can do is differentiate that to get dA by dr. And if I want to cancel out terms to make dA by dt, I need to multiply by dr by dt because these two here will cancel out to leave me with dA by dt. Now dr by dt is something I've already been told, that's equal to 6. Okay, and dA by dr I can work out from here because I can differentiate this and then substitute the value r equals 2 to get what dA by dr is. So let's differentiate a to get dA by dr. We need to multiply by the power to get 2 quarters, which is a half, pi times, now we need to take 1 off the power of r. That leaves me with just r, and then we substitute r equals 2 to get a half pi times by 2. 2's cancel out to give me just pi. Alright, so I'm almost there now. dA by dt is equal to pi because that is what dA by dr is, multiplied by dr by dt, which is 6. So overall the answer is 6 pi. Okay, so nice straightforward example to begin with. This next example is slightly trickier. Liquid is pouring into a container at a constant rate of 30 centimeters cubed per second. At time t seconds, liquid is leaking from the container at a rate of 2/15 V, don't forget that V, centimeters cubed per second, where V centimeters cubed is the volume of liquid in the container at that time. And then it says show that, you get that equation there. So minus 15 dV by dt equals 2V minus 450. So I'm going to do everything from the perspective of the rate of change of the liquid inside the container. So I'm going to work out dV by dt based on what's inside the container. So you've got the liquid entering the container, so that's being added, and then you've got the liquid leaving the container, which is 2/15 V. And the reason why it's negative is because it's leaving the container. Now all I need to do now is multiply by 15, and if I do that, I get 15 dV by dt equals 450 take away 2V. Now to get the equation I've got up here, I just need to multiply every term by minus 1, and if I do that, I get minus 15 dV by dt equals 2V minus 450. So other than the initial setting up of the equation, it wasn't actually that difficult. Now this next question is a little bit tricky, and we're going to have to use various different elements of maths to actually solve it. So first of all, we need to know about inverse proportion, okay, and how we can recognize that. The next thing we need to know is a little bit about trigonometry, and volume, and finally what the whole thing is about, which is calculus. Now we're going to break down the question, hopefully, and you'll understand where to go with it. But let's just see what we've got. An inverted conical funnel is full of sand. The sand is allowed to leave by a small hole at the bottom, and it leaves at a constant rate of 6 centimeters cubed per second. Given that the angle of the cone between the slanting edge and the vertical is 30 degrees, show that the volume of the salt is 1/9 pi h cubed, where h is the height of the salt at time t seconds. Show that the rate of change in height of the salt and the funnel is inversely proportional to h squared. And finally, write down a differential equation relating h and t. Now, as you can see, there's a lot of information to absorb in that question. And what I like to do, wherever I can, is to draw a diagram to help me. So what we've got is an inverted conical funnel. So let's just draw that. So something like that. Okay, so this is my inverted cone. And it says the height is h. Okay, so let's just put that on. And the angle between the vertical and the slant is 30 degrees. All right, and the radius would be r there. Okay, now the reason why I put that there is because it wants everything in terms of h and t. So the first thing we're going to try and do is express r in terms of h and t, because it is going to be important. So the height is this vertical height here. So what we can say is that tan 30 degrees is equal to the opposite over the adjacent, so r over h. So r is equal to h tan 30, and because tan 30 is 1 over root 3, this would be h over root 3. Now the volume of the cone is pi r squared h divided by 3. So let's just write down what r squared is. R squared would be h squared over 3. So the volume is going to be pi r squared, so pi multiplied by r squared. Remember, r squared is h squared over 3, multiplied by the height, all divided by 3. And if I simplify that, I'm going to get pi h cubed over 9. And that's the first part of the question answered, because this is what we wanted to show. Now the last two parts can be done in one go, as long as I know how to recognize when two things are inversely proportional to each other. So if y is inversely proportional to x, we say y is proportional to 1 over x, which means y is equal to something over x. Now in the same way, we want dh by dt to be inversely proportional to h squared. Okay, so that there is what we're heading for. But we need to think about how we're going to get there. dh by dt, I need to write it using a chain rule. Now from this I can work out dv by dh. Remember, this is equal to v. Okay, v is this bit here. So what I know is that v is equal to pi h cubed over 9. Alright, which means dv by dh is equal to 3 pi h squared over 9, which is pi h squared over 3. Now dv by dh, if I flip it upside down, becomes dh by dv. So let's just write down dh by dv first, and then think about what I need to multiply dh by dv by to get dh by dt. So we need to cancel out this dv and then introduce a dt, so that'll cancel that out, leaving me with dh by dt. Now let's see which of these things I've got. dv by dt is over here. That is minus 6. Now the reason why it's minus 6 is because it's leaving the container, not entering the container. And dh by dv I can get by doing the reciprocal of this. Okay, so that would equal 3 over pi h squared multiplied by minus 6. And that'll give me minus 18 over pi h squared. Alright, so let me just write down dh by dt over here. So that's what we're aiming for. Okay, something over h squared, and this is something over h squared. This is minus 18 over pi, all divided by h squared. So it satisfies the inverse proportion condition, and that is the differential equation relating h and t. And there you have it. That's my 3 examples done, and I hope they've helped you to understand how to use calculus to solve rates of change questions. Thank you for watching and listening, and I hope to see you again next time. Goodbye for now.